Thank you, Francisco, for this nice talk. The second part will be more technical part, and I will do it in English. Sorry, but I cannot speak Spanish. So after the selection by Francisco and the University of Montevideo, we start some practical trials at pilot scale mainly, and also industrial scale, in order to fine-tune all the possible application of this unique yeast. And the first step was to produce the yeast as activate dry yeast. It was initially produced as liquid starter, and you can imagine that is not really convenient for logistical reasons. So we managed to produce this yeast as dry yeast, preserving all the performances and properties of the native yeast. And with this dry yeast, we performed several trials, mainly in Europe, Spain, Italy, and France, on still wine, white and rosé wine, on base wine for sparkling, with traditional method or charmat method, and even on cider to see if it could be a possibility. So first trials, we start with trials in Ribera del Duero with the winery Comenge. Trial firstly on white from Albilo grape variety. And we had the opportunity to have the support of Antonio Morata from Madrid to monitor with the winemaker all the trials. So I have only a summary of the main results, but all the results have been published in 2020 in fermentation. And in this trial, we compare VINEAE, Fermivin VINEAE, which is the commercial name of the Hanseniaspora VINEAE selected by Francisco Carrao, versus our Fermivin 3C, which is more dedicated to Chardonnay fermentation. All the fermentation has been done in pure culture, so till 12 degrees alcohol in 1 hectoliter tanks and in triplicates. So as you can see on the table, there is no real significant differences between the ferment with Cerevisier and the ferment with VINEAE. But we observe the same property in terms of aroma production than during the selection done by Francisco. And the main traits that can distinguish Cerevisier and VINEAE is the overproduction of 2-phenylethyl acetates. And you can see that with VINEAE we reach very high level of these compounds that impart noticeable floral notes to the wine. We also monitor the cell autolysis and the lees aging. So it was a separate experiment done in the University of Madrid with the two different biomasses from non-Sac and Saccharomyces cerevisiae. And what we observe is that VINEAE is well performing in terms of release of nucleotides and amino acids that can increase the complexity of the wine. And in terms of polysaccharides, it's not the best in terms of level, but this measure was the final point. And actually, and Francisco mentioned it, VINEAE has a faster autolysis. So you reach the highest level of polysaccharides faster than for the other yeast. Other application on rosé wine in the same winery the year after, with the same comparison, VINEAE and 3C, with a difference. We did some experiment in stainless steel tanks, but also in barrel, still with pure culture and in triplicate. So same impact in terms of overproduction of 2-phenylacetyl acetates. We also observed the production, the liberation of isoprenoids compounds, and mainly linalool, due to the glucosidic activity of VINEAE. So interesting in terms of increase of complexity of this wine. What is also interesting is the impact on color, which is an important parameter for the rosé wine. And you can see that obviously there is an impact of the tank, barrel or steel, stainless steel. But we can also observe visually or analytically that all the ferment with Hanseniaspora VINEAE are less yellow and more reddish, which is a nice property to have more trendy rosé wines. In terms of sensory, on those wine, you can see on the graph the impact on the floral but also fruity aroma profile, on the body and sweetness in mouth, and the tonality, the wine are less dark than with Saccharomyces VINEAE, which is a good point for the rosé production. Let's move to... No? No. Next slide. Okay, thank you. So let's move to bubbles. So we performed some trials on base wine in Trentino, North Italy. You have here some results also presented last year in macro wine by the team of Thomas Roman in Fondazione Mac. So on Chardonnay with pure fermentation, comparing with Fermivin VINEAE, still the same Fermivin yeast. And you have here some results in terms of aroma profile with the same traits. That is to say, overproduction of 2-phenylacetyl acetates, a lower level of 2-phenylethanol due to the acetylation of this alcohol, and similar level of different level of ethyl acetates, higher level of ethyl acetates with VINEAE, but not really problematic. We also did some fermentation for Prosecco production, so on Glera based wine, and with Charmat after the first fermentation. So still VINEAE, but with other Fermivin yeast, LVCB, and a mix of LVCB and 4F9, which are the best yeast for this production from our range. And you can see that we have the same traits with the 2-phenylacetyl acetates and the 2-phenylaethanols. And as mentioned by Francisco, we also observed higher production of benzenoids, mainly benzyl alcohol. What is also interesting and could be very useful for the second fermentation is a lower production of medium chain fatty acids, which can be toxic either for yeast or for bacteria. So in both cases, Chardonnay for traditional method or Glera for Charmat, fermentation with VINEAE leads to very distinctive aroma profiles, convenient for blending or for wine diversification. We also extend the use of VINEAE to cider with one experiment at lab scale in triplicate. And again, VINEAE resulted with the highest level in 2-phenylacetate acetates. So it's really a consistent trend. And for the ethyl and methyl esters, you can see that the levels are not so high. So that explains that the sensory, with the sensory, we have a very distinctive aroma profile in terms of cider. It's a real diversification in terms of aroma profile with floral notes and sweetness, syrup and baked apple in those products. So how to use Fermivin VINEAE in the winemaking process? To guarantee the complete achievement of the fermentation, we recommend the sequential inoculation of Cerevisiae. And as VINEAE is a fermentative yeast, you can monitor the implantation and the development of the fermentation by VINEAE, and after a loss of 30 points of density, inoculate the Cerevisiae for the achievement of the fermentation. We observed a good combo between VINEAE and Fermivin VINEAE, but other combos are also possible, since VINEAE is a very friendly yeast to get other wine profile. What we observe, and you have here some results on Sauvignon Blanc in France, is that VINEAE is not really adapted for sialic wines, since this yeast has not the property to release ciols from their precursors. At what time, what is the best timing for the sequential inoculation? We recommend after a loss of 30 points, and actually we also try other late inoculation, sequential inoculation, but there is no improvement with the late inoculation in terms of aroma profile. You can see here that we have the same profile after 30 points, a loss of 30 points or 50 points. So better to do it at 30 points to have the good achievement of the fermentation. So as a conclusion, this yeast is a really a unique yeast, fermentative non-sac, which could be used till 10% alcohol, even if we recommend to do a sequential inoculation just after 30 points, the loss of 30 points of density. Convenient for white, rosé, and sparkling-based wine production, even cider. And we are investigating also the adaptation to the fermentation of base wine for distillation. The autolysis is really fast and could fasten the lees aging to have wine with a very nice mouthfeel early during the aging of wines. But this yeast has some special requirements. So the rehydration should be done at 30 degrees instead of 35, 37 for the Cerevisiae. We recommend a systematical addition of thiamine to avoid any volatile acidity production, because we don't know the level of thiamine in the must, and it's not easy to measure in terms of with the production during the production of the wine. And ammonium is completely forbidden when VINEAE is fermenting, because it will affect dramatically its viability. So it could be used for the sequential, it can be used for the sequential fermentation, and even could be also a tool to induce the death of the cell and start the autolysis. But if you want a good viability for the VINEAE fermentation, don't use ammonium. In terms of nutrition, the good combo is to add thiamine with the yeast, with VINEAE inoculation. And then with the sequential inoculation of Cerevisiae, you can use different nutrients, complex nutrition, ammonium, or organic nutrition. And we recently did a trial that demonstrates that using our yeast autolysates, Natufem Bright, which is rich in amino acids, with the Cerevisiae sequential inoculation, you increase the level of acetates from aromatic alcohol, and especially the level of 2-phenylacetate. So you can improve and promote this overproduction of 2-phenylacetates using organic nutrition for the sequential inoculation and fermentation. Thank you for your attention.